All right, welcome to the last session before lunch. And we're going to talk about music, something I really love. And I want to take you back to 1972, March 4, essentially. Greatest day on earth. I was born. And a month later, the Roland company in Japan was founded. And you might know Roland of creating keyboards, DJ gear, and whatnot. And in 1980, they had this commercial art.
Producing the world's most advanced rhythm machine, the Roland TR-808, a revolutionary computer-controlled rhythm machine offering more percussive variations and effects than virtually any other machine on the market. Rhythm pattern visualization, built-in memory, realistic sounds, synchronous performance. Roland, we design the future.
They were designing the future in 1980 with Tron-like animations. It's like way back in time. They created the TR-808, the first, not the first drum computer, but the first of its kind, let's say. It costed about $1,200, so about, if I'm correct, 12,000 Swedish kroner, something like that. Pretty hefty price. They produced 10,000 of it and maybe sold a few hundred. It was a complete disaster. But however, in 1983, well, this was the 808, by the way, lovely, heavy stuff, had this sound, the cowbell. This was a total flop, the 808, but many years later, quite a famous song was produced with it. Maybe you recognize it. I see faces smiling. Shout it out if you know. Yes, Whitney Houston. I want to dance with somebody. Feel free to dance if you want to today, by the way. So sort of 5-6 years later, it came up and also was used in hip-hop songs, by the way, a lot. But in 1983, they come with this beast, the TR-909. More or less the same price, more or less the same amount of devices produced. They didn't have a fancy advertisement as far as I could find. They had this. It's like just a lot of text. I don't know why, but it says things like, is the TR-909 rhythm composer the best sounds, the best programming, the most flexibility, the most expression and whatnot. And I love this quote. It says, it means that years from now, when other drum machines are sitting in the closet gathering dust, your TR-909 will still be on the job. That's sort of correct, but also not, because it was a complete disaster as well. They ended up in the second-hand stores for, I don't know, more or less 500 Swedish krona. You could buy one. Until this guy came along in around 88. This is Tyree Cooper. He's a DJ producer from Chicago. And what they did back in the day, they were having house parties in warehouses. And he came up with the idea of creating music with this sequencer, with this drum machine. Madonna used it as well in her song Vogue, for instance. What about these guys? They even call their song TR-909 Revolution, Daft Punk. And let's see if you remember one of those songs as well. If you know it, shout it out. Pump Up the Jam, yes. Eric E. and Jakit K. from Belgium, Technotronic. And one from my, a little spoiler, one from my own country, if you know where I'm from. Ray and Anita, yes. Fun times. That's the music I grew up with. Essentially, I used to be a club DJ in the late 80s and early 90s. So this was the music I was playing on vinyl. Great stuff. And I built my first website in 1996. Nowadays, I've been a jack of all trades, but nowadays I'm a front-end focused senior DevOps engineer with special attention for accessibility and usability. And maybe next week I add another word as well. Why not? I'm also recently became a Google developer expert in web technologies, especially on PWAs. I have a talk tomorrow about service workers. So if you want to know more about that, 3 o'clock, I think. And also, it also involves Project Fugu. And Project Fugu involves browser APIs. One of them is the Web Audio API. So let's dive into a little bit into the Web Audio API. It's built in your browser, and you can create music or noise or sounds, whatever, or manipulate stuff with it. And it's very well supported. It's in all the browsers, all the major browsers. To give you a little example how that works is that we need to create something that's called an audio context. That's more or less the wrapper around all the stuff. And the way to create that in JavaScript is like this. We, for instance, call this a CTX and say it's a new audio context. That audio context needs something. That needs an oscillator node. An oscillator node will generate the waveforms that your ears and your brain will transpile into sound and music. The way to do that is we create one and we hook it up to the audio context, but it needs more. For instance, it needs to have a frequency. Frequency is in hertz. The lower the frequency, the lower the noise or the sound, the higher the pitch. So for instance, we take 440. That's a more or less generic frequency if you are a musician. That's the E, I think, or the A. The A, thank you. I always mess them up. Good. We have musicians, good. But we also need a waveform. And a waveform, that's more or less how nice it sounds to you or how pitchy it will be. So we can use 4 different ones. We have the sine, for instance, and be aware of your ears. That's more or less fluent, nice. You hear some clicking, but that's I'm going up into the frequencies. We have the triangle, that's more or less like sine, but it's more edgy. We have the square. This always reminds me of 1980s games, computer games. And the sawtooth, that's like slowing up and just dropping it. So with all these kinds of sounds, you can create stuff. And for instance, if we do this, we have a frequency of 440 with the sine. We can now connect it to the audio context destination. And destination in this thing is your speakers, or these speakers in this case. We can start it and we can stop it, in this case, after 2 seconds. We are not using set timeout or something. We're using the current time of the audio context itself, because that's way more accurate than set timeout or anything else. So this would sound like... There you got your A. I warned you. All right, but nice. I want to create something like this. I want to make beats in the browser. That's what the talk is about, right? So what I can do is create those sounds like a kick or a snare with the Web Audio API. It sounds like this, for instance. Okay, nice. Sounds quite all right, right? However, look at the amount of data I have to write, or the amount of code I have to write. I'm gonna have a drink in the meantime. Just try to memorize it and take photos or whatever. It's like creating noise buffers, I don't know, linear ramp out to value, biquad filters. Oh, that was only the kick, by the way. Now we get the snare. It's even more. Yeah, that's a lot, right? Have a noise filter of a high pass and whatnot. So this is only 2 sounds. Imagine if you want to have 16 or whatever. So that's not really a good idea. Let's go back to something that's created in 1991 already. The WAV format, so the waveform audio file format from Microsoft and IBM. It's completely uncompressed, very high quality, good for little samples, not for like whole songs. Then you'd rather have an MP3, for instance. So if we want to recreate those beats, those sounds, we're going to use WAV files. So let's say I have a little interface here in the browser that has 4 pads. Those pads are essentially buttons. We can click on it. They have two data attributes, data node, that will become interesting later on, and a data wave. So which wave files should we play if we hit that button? I'm going to select them all. And for each pad, I'm going to say, well, we're going to add an event listener on click. And if you click it, we're going to load that file that's in the date wave attribute. So the kick, the clap, closed head, or the open head. You can see we have to write the load file method in the end as well. We're going to get there. And then I'm going to say, well, play this sample, play wave this sample. So we have the load file and the play. The load file is essentially like you're doing an API call. You can fetch the wave file from your local system or maybe an external system. However, to be able to use it, we have to create an array buffer from it. And then again, have to decode it for the audio context to be able to use it. And we can return it. So now we have that wave file ready for the Web Audio API to use. We're going to pass it to the play wave method. And to be able to use it, it will create an audio buffer source node with that buffer you just gave. We connect it to the destination, so the speakers, and now we can say start. But there's an easier way. This is still a lot of code to write. If we use a library like Tone.js, that is an abstraction of the Web Audio API, so it's way easier to interact with it. It's a free, an open source JavaScript library with a lot of functions and a lot of things you can do with it. But let's start simple. Because you saw that I wanted to load that wave file, I had the load wave and the play wave. This is what I can do with Tone.js. I can say, well, give me a new player with this wave file and send it to a destination. And if I do kickstart, then I've kickstarted my kick. So 2 lines of code to have that wave file available for you. So instead of having all this and this, we can now skip the data wave, for instance, and we're going to use the nodes. We're going to preload everything that we need, like we saw in the previous slides. And we, again, of course, going to query all the paths to get the proper click event there. And I've used a switch statement here to see which data node was hit, and then we just play it. It's already a lot easier. However, I don't like it just to play the buttons in the browser. I would like to use, for instance, this device. This is a small USB MIDI device, which I can use with the Web MIDI API. And the Web MIDI API is an interface for connecting these things to your USB port and be able to use it. MIDI has been around for many years. There are musicians here, so they should know. Because it's a generic interface for musical instruments. It's well supported, except for Safari. I have no idea if they're ever going to support it, but you have enough. You have enough alternatives. Yeah, I'll get back to Safari. So this device, I want to have this device. You can see this device has pads on it, right? It has 8 in this case, even. So what I can do now is I can check whether my browser supports MIDI access. Because Safari doesn't, I have this if statement. If navigator.request MIDI access, then apparently it supports it, and I can request the access to the device. If it succeeds, I get the success callback. And that success callback opens a new world for me. I get MIDI access back. And MIDI access has a lot of things in it, like what's the device brand, or the version, or the name of it. But more importantly, I get access to the inputs. The inputs are the outputs of the device, so that's a little mind trick, but it's the inputs you get in your browser from that device. It could be 1, usually it's 1, but it could be more as well. So what we're going to do is for each input that is there, we're going to add an event listener that listens to the event called MIDI message. A MIDI message is every time I press a button or I turn a dial or whatever I do with the device that recognizes that I'm touching it. When we get that MIDI message, we're going to call a method called handle input. And then we can do funky stuff with it. But first of all, that MIDI message, how does it look? Well, it's essentially very simple. It's an array of 3 integers. And the first one, for instance, this one, 144, is the command. So what am I doing? Am I pressing it or releasing it? It's only 2 values it can have. Unfortunately, it's not true or false. It depends on which MIDI device you have. So in this case, I think 144 is on this device. And if I release it, it will be 128. So you have to tailor it to the MIDI device you're using. The same goes for the second one as well, because the second one is the note. And it's kind of weird if you are touching a pad here or turning a dial. That's not really a note, but it's more like which button or dial did you touch. That's the note. Some have a few, some have many, for instance. And the last one is the velocity. If you have a keyboard and you hit it really hard, that it almost breaks, you get 127. That's the hardest, the loudest you can touch it. And if you release it, it will be 0 because you don't touch it anymore. All right, this one. We had the buttons with the notes. And now I want to use it with my MIDI device. So I have my handle input, as I said, and we get the input there. What I do want is the note and the velocity, because I don't really trust the command like releasing it. So I'd rather use the velocity. If it's 0, then apparently I released it. So the note will be the second one in the array and the velocity the third one. As I said, if the velocity is over 0, apparently I just hit the button. Then I'm going to select that button that's appropriate to the note I just touched. And I'm just saying click. So I can now do it in the browser with my mouse or my touchpad or touch screen, for instance, but also with that MIDI device. You want to see that? Yeah, okay. Let's do that. Let me put it. So if I do it now in the browser with my touchpad, I get a kick. But I like hardware, so I'm just going to plug in this one. It lights up nicely as well. I need to say, well, connect me to this MIDI device. And if I do that, you can see it says it's an Akai Professional LDP8 MK2. Wow, fun. More importantly, I can now do this. That's more fun, right? I never know how these demos go because I'm always out of sync or whatever. I did this one. That's good. All right. Let me take a little sip. But I want to have this one. I want to be able to create a sequencer and not just like doing this myself the whole time. If you don't know what a sequencer is, essentially it's you sort of record a pattern and you just keep on repeating and 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 repeating. Yeah, you get the idea, right? You just keep on repeating. And that's essentially what house music, EDM, acid house, or whatever you want to call it, is based on. Every modern producer is just do it not with real stuff anymore, essentially, but doing it in their computer, dragging stuff like, okay, let's repeat this over and over and over again. I cannot afford a TR-909 Because nowadays they are sold on eBay and stuff for about, let me multiply it by 2, more or less 14, 15,000 Swedish krona. That's quite a lot of money. I just got solar panels. That's more or less the same amount I had spent on that. So I got this one for about 200 krone, I think. This is also a MIDI device, again with the USB connection. And I sort of can mimic a sequencer. On the original TR-909, you had to switch, like you only had 16 buttons. And if you want to have a different instrument, you had to switch dials and then you can program it again. I'm lucky, I have 4 rows I can use. So that's improvement. In the browser, you can, later on I'm going to share the link as well. You can do it in the browser as well without that MIDI device. So you can see in the top left, I can pan low. That means I can set the low sounds to left or right on the speakers. Let's try if it works later on. The high notes as well. I can change the pitch. I have some wave files that are not drum sounds, but are samples. So I can set the pitch to very high or very low. And I can control the BPM, the beats per minute. So how fast are things going? This is the essential part. This is the sequencer. This is the 16 steps I can program. With one in the front, that makes it easy for me to just program, but don't let the music sound. So I can mute it. That's the word I was looking for. And how does a row look like? Well, like this. Again, with the inputs. They're all checkboxes. The first one has a data mute. So I can in my code see, well, I want to mute the kick. And the other ones are related to the buttons I have here, going from 54 to 69, on and on and on. We have that handle input again, so I get the note and the velocity. And essentially, I have an extra if statement here, is that I only want to respond to notes 54 till 117. So those are those 4 lines that I have. And if I hit it, it will just check mark it. Because when it's check marked, I can start the sequencer, and this one will just keep on repeating and repeating and repeating it by 16 steps. Also with the Tone.js library. This is a little bit simplified, but what it does is that it will look which one is selected or not. And if it's selected, it will play that sound. Only if it's not muted. And at the end, it will just increase the index again to keep on repeating it. One other thing you can do as well, I don't know what the average age is in here. Way less than mine, I can see that. Any idea what this is? Cassette tape, thank you. There are older people in the house. Cool. This is not a disappointed emoji or whatever. No, this is a cassette tape because Tone.js always also gives you the opportunity to record the shit you are making. So also very easy to do with Tone.js. I can say, give me a new recorder. And if I want to record this, just recorder.start. And we're going to wait on it. And stop is a wait for the recorder to stop. And what I do here is that I create a new audio element, an HTML5 audio element, and just put that recording in there so I can play it. And in this case, append it to my interface. All right, I'm going to use this one, as I said, but also this one, because why not? There's one particular reason, because you can see, let me go back. You can see the dials on top. Unfortunately, this device only gives me 0 or 127 and nothing in between, though. That kind of makes it hard to set the BPM somewhere in the middle of the range or left and right. So I'm going to use the other one as well, because they work, I know. All right. Are you excited for it? Oh, that's already better. That's good. Let me plug this in. and pray to the gods this demo will work. Let's see. Let's go to a different one. I'm going to the sequencer here. Yeah, one thing that's also very necessary is that you make sure there's a user interaction before you can use the Web Audio API, because otherwise, like we had way back, websites will just start playing. I see Phil going on. You have websites playing ridiculous MIDI files or whatever. It's like back in the 90s. Yeah. It was horrifying. So they changed that. So you have to say, well, I'm gonna have user interaction there that it will be able to use the MIDI audio API. So it also needs interaction for that MIDI device to connect. So let's see if they want to connect. Yeah, there you go. I have the FL Studio Fire, that's the large one, and I have the LDP8, that's the small one. Now I need to calibrate my buttons a little bit. You can see if I turn this one, the left top, this is the left and right. I have to make sure it's in the middle. These are the highs. It's mono. Well, just have to believe me then. Or try it at home yourself. So this is the pitch. Let's set it in the middle, and the BPM. You can see I can go from 3 BPM, so 3 beats per minute, to 200. 200 is a little much. I think back in the day when we had the hard style from the Netherlands, it was about 150, 160. That was fast enough. So let's start at a decent 120. All right. Let's just hit some buttons. So let's say I'm programming this. These are the kicks. And I also have a start button on this device. So let's hear it. All right. We have a beat. Let's mute this, because I can do this in private now. I have no idea what I'm doing, but let's see how it sounds. Oh yeah. All right, let's record this. And I can say, well, let's see if he's right. Oh, it just kills it. Yeah, well, sort of left and right. All right, let's see the BPMs. Let's get it slow, nice and slow, or just... You can see, thank you. I'm not done yet. You can see there's now a player in there, and we can relive this awesome mix again. Let's not call it an awesome mix, but it gives you an idea of what you can do. Let me refresh this, because I haven't shown you the pitch, right? Let's put the BPMs. Let's make sure this is all in the middle again. So let's put the BPMs here. Let's program a little bit. The one thing is I have to, you see I have an issue here. I have to put this on or off, essentially. So, and now we're there. More or less. Hold on. So I've reset everything. All right. Let's see if I can do some weird stuff as well. Let's program the bass line again. And this kick as well. All right. Bear with me.
The music take control. Let the music take control.
And let's make it more annoying. That's enough noise, right? All right, let's move on a little bit, because I have a little extra and another extra. The Web Bluetooth API. That's also something that's in most browsers, but not all. Not in Safari and Firefox. The Web Bluetooth API supports Bluetooth low energy devices. For instance, light bulbs you can use, or I have a little robot you can control with it. I don't have it here, sorry. Or some other stuff as well. And it can, you can either send stuff to it. For instance, the robot, you can make it move, or you can have a light bulb change color, or you can receive data, and we're gonna receive some data for that. The basics, I'm not going to go into deep, but the basics are that you request access to a device. That will pop up a security thing in your browser as well. And what's smart to do is say which device you're looking for. I had a friend of mine doing this at a conference, just searching for all Bluetooth devices with about 250 people in the audience with mobile phones. Mobile phones have Bluetooth. Can you imagine what happened to Google Chrome? So always search for the appropriate device. And if you get a connection, we're going to create something that's called a server, more or less an array of objects. From that server, we are picking a particular service. And in this case, with this particular UUID. That's more or less an object. And from that particular object, we're going to get a property, a characteristic. And what we can do with that, the most important part then comes with that characteristic. For instance, we can start listening for notifications, start listening for things to change. And the thing I brought is this one. This is a heart rate monitor. And what we can do is we add an event listener to the characteristic value change. That means every time the heart rate monitor gives some information back, we can act on it. And in this case, I love BPM as a DJ, but what about HBPM, heartbeats per minute, right? That's even more fun. So if we get a value back, I can set, that's then my HBPM, and I can say to tone, this is now my new BPM value. Let's see if that works. I do need a volunteer, by the way, who is willing to get his heart rate up. Because 2 weeks ago, I did this at a conference in Sofia in Bulgaria, and I jumped off stage and something in my calf just went snap. So I can walk, but I cannot run anymore. But let's first see what my heart rate is. So if I go back, refresh this. What I also did was setting patterns. So for instance, anybody remember Faithless? God is a DJ. All right, here we go. This is more or less the soundtrack of God is a DJ. Sounds nice at 1:30. But now I want to connect this device. So I'm going to put it on my arm. just like that. And you can see you have a permissions dialog on the top. A polar sense it is. And I can say pair. And what is my heart rate? 87, 88. Okay. That's okay. But if you have God as a DJ, it's more like granny style. Oh, 91. I'm getting anxious apparently. Maybe I can get it up. I'm like, oh, I don't need anybody to run apparently. Well, you get the idea, right? I had it to 145 at some point. It's like, I don't know if that's okay for my heart, but it's fun. It's fun. So this is just a small example of what you can do with Web Bluetooth API as well. You can combine stuff, and that's fun. And by the way, all these devices I'm using here, I'm good, are more or less around 200 Swedish crowns. So it's not too expensive as well. That's nice. You don't have to buy. Sorry, 2,000. Yes, I have to multiply it by 10. So no, then it's 10,000. Thank you. All right, a few minutes left before lunch. I want to show you something else as well. I'm not going to explain the code. You can have a look at it later on. But there's also something fun you can do with the Web Audio API. And that's visualizing sounds. Usually I stop after doing this shit and don't talk anymore. But yeah, well, let's see. So I have an analyzer here. And it has fun stuff in it. In the middle, you'll have a volume meter, like going up and down. That's one of the things I admired the most when I was a DJ. By the way, the club owner gave me the key to the club. So during the week, I would go there and practice and listen to new files. By the way, I was 16, so thank you for the confidence. By the way, I usually left a little bit early because the rumor, more or less, was, or the myth, that some girl had died on the stairs a few years before that. So when you're alone, you're 16, you're playing music, and you hear footsteps above you, you're done mixing. You're going home. All right. Probably nobody knows this song, but it has nice variations, so you can see what you can do with visualization. Let's hear it. And this is all JavaScript with canvas elements. Drop. I can watch this for hours. Here we go. Well, we can listen for 6 more minutes, or just can say, well, it's been enough, we are hungry. But have a look at the code later on, because I want to say thank you. Tack. Look at this adorable kid. I was selling my own mixtapes back in the day for 10 Dutch guilders, so that's more or less 10 kroon now, something like that. So making big bucks. If you want to have the slides, the demo code, you can run this. It's a GitHub project as well that you can run locally. Go to rowdy.code/Øredev1, because tomorrow you can look ahead if you want to. There's an Øredev 2 as well for the second talk tomorrow about service workers and working offline caching stuff for your users. So if they have a spotty connection on the train, for instance, they still can enjoy your website. So hopefully see you tomorrow, and otherwise have a nice lunch and maybe see you later as well. Thank you.